What is the role of mobility in the spread of COVID-19? I'm Gioia Boschi, a fellow here at faculty, and today I will talk about how I have helped NHS modeling the spread of COVID-19 using mobility data. As we all unfortunately know, mobility plays an important role in the spreading of infectious diseases. However, it is not clear how how mobility has influenced the spread of COVID-19 in different UK regions, why some regions have been hit harder than others, and how changes in mobility due to lockdowns or other measures have influenced the course of the spread. To answer all these questions, I've developed a machine learning model to predict positive tests in different UK regions that will help NHS understand how to use mobility data for future modeling. For my model, I've used three data sources that are mobility data that provide an estimation on the amount of people moving between different regions, testing data that provide an estimation of the cases of COVID in different UK areas, and rural-urban classification that provide an indirect information on how densely populated are the different areas and how likely people are to meet inside or outside. The areas are very small. In fact, if you take the UK map here and you split it in local authorities, as you see, and you split them again in smaller pieces, you get MSOA, that are middle layer super output areas the areas that I'm looking at. These areas are about of the size of 19 square kilometers and have an average population of around 8,000 people. For each of these areas, I've extracted interesting features from the data, like the intra-MSOA mobility, incoming mobility, COVID-19 cases in the area, but also COVID-19 cases in the areas where people are coming from, and other features. All this data are then put together and used by a machine learning model to predict positive tests 1 and 2 weeks in advance. The two approaches that I've used for modeling are linear regression and XGBoost. The final model that I've developed explains 68% of the positive test data 1 week in advance. So the model has a good predictive power. Moreover, when taking a simpler model that uses only testing data, so historical testing data, and I compare it with my model that uses also mobility, I get that my model guarantees an increase in performance of 15% respect to the simpler model. And this shows how important are mobility data for predicting positive tests and why NHS should include them for future modeling. Apart from model performances, there are other insights that can give useful information about the problem. For example, measuring different data importance or the predictive power of different data sources can help NHS understand which data sources to prioritize in future. For example, in my model, the rate of positive tests in the areas from which people are coming is more informative than MSOA mobility of the area we're looking at. Other interesting information come from the importance of different data and models performances and how these depend on the area for which we want to have predictions. In fact, for example, in my model, I get that model's performance for major urban areas is worse than other rural areas. And this raises interesting questions on like which are the factors that we are missing in urban areas that contribute to the spread of COVID-19. Are there other factors that we have to use to predict COVID-19 tests in these areas? The impact of my project is wide. In fact, a possibility for NHS is to take this model one step further and use it to predict hospitals' admissions and bed usage. Moreover, NHS can anticipate changes in COVID-19 prevalence starting from this model when mobility changes. Another possibility is to use this model to start understanding why some UK areas have been impacted more than others. And finally, the model will help NHS prepare for future pandemics, understanding the role of mobility for future modeling. Thank you very much.